Only halving and doubling are generators. These are not generators because I can't get all the other states by applying this operation. Everybody clear? But it turns out these two operations are super important. All right, let's do, oh, here we see them closer, right? Thank you, Marco, for putting these in. This is the 6 cycles looking, oh, okay, that's the do nothing. They're not quite in the right order. That's the 6 cycles, that's the doubling. And okay, this is a little better. So this is the twice doubling. I like to call this the F cycle. This is the R cycle because it's moving in reverse. Okay, so the 1 goes to do, and the do goes to 4, and 4 goes back to 1. That's 1/4. You could say it's quartering, okay, or I call it the R cycle, and the one that goes the other way is the F cycle. But I don't know. We can come up with different names for it. And then, of course, swapping. You've seen that. And I don't even know what's coming. This is the F cycle because it's going forward 4, forward 4, forward 4. And we get that special case. We get these 2 triangles. We're going to come back to that. That's kind of important. All right, and I just quickly wanted to show you tripling. Tripling, if you multiply 1 by 3 in mod 5, you just get -2. So it's just the same as doing a halving. It's the same circuit as halving in mod 5, so that's not very interesting. Mod 9 tripling is not even a group action, and I just wanted to illustrate this. Wait a minute, this is the wrong one. This is the old one. Yeah, this is doubling. I'm sorry. Well, if you can imagine, you're just going to have to use your imagination. This is the wrong slide. Tripling E1 would go to E3, but tripling E4 would also go to E3. And tripling E7 would also, because 4 times 3 is 12, and 12 mod 9 is 3, right? And -2 mod 3 times is 2 at a time. -2 is also 3. So I get 3 numbers that go to 3. The 3's and then -3 times 3 is 9. So that's not even a group action. To be a group action, everything has to go to something else. They have to flip through. Make sense? So tripling is not a group action mod 9. It is a group action mod 5, and it turns out that it's a generator mod 17. And I know you can't see it, but you're going to cycle through all 16 states. That makes it a generator. I can get all the actions from this one action. And I'm sorry you can't see it clearly, and it's not even the right one. But hopefully you get the idea, so we'll move on. So again, I said this before, this is the same as having, this is not even a group action, and this, for mod 17, is a generator. So it's different for different groups. All right. I never know what's coming next because it's changed from what I had before. So that's the wrong slide. That's not a group, but I've already talked about it, so I'll just move on. Okay, here's another aha moment. We're just about there. Any true statement, this is so cool. Any true statement involving the elements of a group remains true when the elements are shuffled. So if I have something that I know is true and I do a shuffle like any of those group actions, that statement will also be true. Is that cool? That is 100% true with all groups. Now, Rodin maps and 4x4 magic squares are true statements. So I should be able to take any of those. Let's say, for example, we know doubling is a group action, a valid group action, mod 17 or mod 9. So I should be able to take a magic square or a Rodin map and double every element, and I would still get something that's also true, right? I think that's cool. Doubling is a group action. I think that's an aha. I'm hoping that was for you too. So let's try it. Here's a map. Now all I'm going to do, hopefully you can see the bars. So that's 1, 2 bar, and then 6 and 5 bar. Okay. I'm going to double the 1. That should become 2, and the 2 doubled would become 4 bars. 6 doubled would become 12, which is -5, right? Mod 17, and that's what I get. 2 door dive, and then 5 doubled is 10. Excuse me, -5 doubles -10, which is +7. Okay, so I doubled every element, and lo and behold, can you see it? This is the same map. All I did was do a little a knight's move. I moved my 1 down like that. See where it is? And then I rotated it, and it's the same map. Everybody clear? Everybody seeing that? Okay, I'm not getting huge responses. I know you're tired, but hopefully you see that this is true, that's true. I knew it would be because that's what group theory, that's the power of group theory. It told me it had to be true. I didn't just guess at it, I knew it was true. And likewise, if I double it again, I know that's true. And if I double it again, that's also true. Now you're noticing the corners going 1, 2, 4, 8. What do you think the next corner one's going to be? 8 doubled is 16 or -1. This is the reverse of this. All my underlines, I don't know if you can see them. This is the same map as this. Everything that's underlined here is not underlined here. Everything that's underlined here is not underlined there. That's why I like the underline or the bars. It just makes the symmetry so clear. I just swapped everything. Same thing here, same thing here, same thing here. And then this one doubled brings me back. So I'm going to get a cycle of 8 here with these doubling circuits, which makes sense because remember doubling 8 times? I mean, all this stuff is connected. It's pretty cool. All right, let's do it with the Rodin map. So here's a Rodin map, and I'm sorry, this is hard to see. But the way I generate it is I take 1, 2, 4, done, do, door. That's my first row, and I always remember this is what Marco calls a shear 4 map, has the 2 under the 2, and the 1, 2, 4s goes the other way. So this goes done, do, door, 1, 2, 4 going the other way. And then I have to figure out where the 0s and the 3s go, and that always takes me a minute. But I do know that the 2 2s, the second 2 is like a reversed, I do the same thing, I reverse every other one. So I go 2, even though that's a positive 2, that'd be like a negative, so that's like going down 4, and I go down 4 more, and that gives me the +3, so that's a +3. Anyway, I'm sorry, I can generate these maps, that's how I do it. And then once I have that once I have this top 3 rows, then I can just calculate the next one. All I want to illustrate this point, I'm sorry this is hard to see, is if I double every element, I should get another valid map. I know I will. I don't guess it. I know I will because that's what group theory tells me. If I have a true statement and I swap the indices, I'm going to get another true statement. And sure enough, I do. It's just that this happens to be, there are 3 maps. Marco calls them shear 1, shear 4, and shear 7. I call it shear do. This one I think is a shear 4. This is a shear 1. Yep. And then this one will be a shear 4. No, this is a shear 2, that's a shear 4. Okay. Anyway, I cycle through. All I did was double the maps. I doubled every element, I doubled every element. I double it one more time, and you notice this map is identical to that one, except all the 1s become dones, the 2s become do's, and so on. I just swapped everything around. Same stinking map. In fact, you could extend it down. Same process. This is a 6 cycle. I go back to the beginning. Okay? So this is how the Rodin maps. I get the same process through doubling. Interesting, doubling 6 times brings me back to where I started. Big surprise, that's exactly what I got with these maps. So that group theory is kind of valuable. Okay, I'm getting there. Hopefully we're getting some light bulbs. Light bulbs turning on. We're getting close to the end. I want to talk now, switch gears one more time. We're going to talk about derivatives. Remember Euler's number E? Euler figured out that E is the base of an exponential whose derivative equals itself. If we take the derivative, we have e to the x, and we take the derivative of that, that's also e to the x. No other number does that. It's a really cool number. Now, my question to you, what if the exponent is complex? We've been talking about complex exponents. What does that mean in this context? Well, here we go. We're talking about a sequence of numbers. We're not talking about a continuum of numbers. So when we're talking about a sequence of numbers, a derivative is the change between 2 numbers. So it's the difference between numbers, right? Everybody understand? A difference in a sequence is the same as a derivative on a continuum. Okay? The same idea. So the difference sequence of the doubling sequence, 1, 2, 4, done, do, door, equals itself. What's the difference between 1 and 2? 1. What's the difference between 2 and 4? 2. What's the difference between 4 and 8? 4. Okay, what's the difference between done and do? It's done. The difference between do and door is do. Okay, and the difference between -4 and +1 going to be 4 again. Okay? Everybody with me? Because I have to add 4 more, I get to -8. -4 to -8 is -4. Okay? So this, what I'm getting at is I'm getting this sequence of numbers is also an exponential sequence. It's just one that repeats itself. Okay? So that's kind of cool. We're seeing these numbers this doubling isn't just arbitrary. It's actually an exponential sequence, which we would expect because we're dealing with numbers which are base e, which is the derivative of itself. That's why these numbers are so important. That's why they're a big deal. Okay? All right, this graph should have shown up better, but it's just basically a sine graph. What I want to show is we've shown 1, 2, 4, done, do, door is a derivative of itself, okay? I want to show that O33 ODD, O33 ODD is also the derivative of itself. Do you notice, does it look like something? If I plot those numbers on a what is that? Come on, we got some engineers here. What does that look like? That's a sine wave. You can perfectly plot these. It's like sampling points on a sine wave, is it not? Okay, and by the way, we're going to come back to that. Sampling points on the sine wave. The derivative would be the change. So from 1 to 3 would be 3. From 3 to 3 would be 0. From 3 to 0 would be negative 3, right? So we should plot that. Okay, so O33 ODD behaves like a sine wave. This is another reason why I like to have 0 in the middle, because that's the way mathematicians look at this stuff. We have 0 in the middle, right? So I know Marco likes to do, he calls it, 933, 966, and that's fine. It's not wrong. I just like to see it this way, because this is the way mathematicians look at this stuff. All right, but I had another slide in there, and it's gone, basically showing the derivative, but I hope you got the point that it's a derivative of itself. Just shift it over. The derivative looks like a cosine. You do it 4 times, and you get back where you started, right, which is the process. This is and I'm sorry the numbers are so small, but this is basically the horizontal portion of the Rodin number pattern. It goes, every other number gets negative, so I go, this is like a negative number. 0, 1, do, 3, door, 3, do, 1, 0. And then the negative of that, done, 2, D, 4, D, 2, done, 0. Okay? I don't know if you can see the bars underneath it, much less the numbers. What I want to point out is I take the derivative, that's the difference. So if I go from 0 to 1, that's 1. When I go from 1 to do, that's negative 3, or D. When I go from negative 2 to positive 3, that's moving forward. That's moving back 4. Okay, if you remember going around the wheel, that's door, and so on. This is actually one of the other 3 maps. There's 3 valid Rodin maps. This is the 3rd valid Rodin map, and this is the 4th one. I get the same sequence that I had in the top row, and I just can keep cycling through them. When I cycle through those 4 more times, I get the exact same sequence that I started with. It takes 12 times for this to cycle. I think that's interesting. And I'm sorry, I know that's hard to see, but those are the numbers. All right, so I want to think of it, I want to look at Rodin numbers now in a totally new way. I want to think of them as sampling points on a sine wave. Now we're getting there. Okay, so let these numbers, so I have 0 through 9, okay, and this is point 1, 2, 3, 4, door, D, do, done, O. Okay, you notice that door is the negative value, if you can think of the value on the right side, is of the positive 4. These numbers have a value. And if anybody here is an electrical engineer, you know that we don't actually transmit sine waves, analog sine waves. We stopped doing that in the 40s. We transmit digital signals. So it's just like sampling a wave, okay? And now here's something I want to point out, that mod 9, these sampling points look identical to mod -1. Remember that 8 is -1 mod 9? So if I have a sine wave that's 8 times this length and I sample them at exactly the same points, I can't distinguish between these 2 points. You see that? I'm going to get exactly the same points because 8 is -1 mod 9. So I'm getting these same points. Now we're starting to get into some things that maybe we can do some engineering with, because now we're talking about frequencies and their relationships between those frequencies, and that starts to be important. This is where we start talking about resonances and things like that, okay? So these numbers are important here. They're not just numbers for no reason. Okay, so I want you to get that point. And also, just to remember that if you double something 3 times, you get 8, okay? And there are 3 dimensions. Just something to think about. The Rodin maps compare a sequence going counting by 1s in one direction, counting by 2s in another, and counting by 4s in another. But if you were to compare to the next map, it would be counting by 8s. So 8 to 1 is not something we don't care about. We actually care about this quite a bit. And I'll show you why a little bit later. Now I have to take another left turn, I'm sorry. I'm going to talk about something that I'm very, very, very excited about. I think this is something I've been working on for years. And I believe this is getting us very close to what I think is the electron model of the actual electron. I have to take a couple minutes. I don't have any slides for this, but I got to explain this. This is like cool. I mean, I can't tell you how excited I am about this. Okay, I believe that the electron, first of all, I believe that the laws of physics apply at all levels, including the structure of the elements themselves, the atoms themselves. Anybody agree with me on that one? Okay, so somehow all the elements that are within this structure that we don't know, that all the physicists tell us can't be known because of Heisenberg, okay, which I think is a bunch of hooey. That's my own opinion, but that there is a structure and that it works. The problem is that we're talking about a structure that has to have density. It has to have stuff in it, and the stuff has to be literally right next to other stuff. okay? And the problem with that is, I also believe something fundamental, that motion is only understood relative to other things. Okay? Everybody on board with me on that? That's not relativity, that's relational mechanics, which is not Einstein. Okay? Okay, it's relational mechanics. So what that means is things that are even an infinitesimal amount apart have to be moving relative to each other. How can that be? Well, there has to be literally infinite frequencies. There's no other way that they can be moving relative to each other at all levels if you're going to have a structure which is composed of this. And yet, we know that electrons and all these subatomic structures are 3D in some way, then they're filling space, and they have to have stuff that's moving around them. So I believe that they're composed of stuff, and that the stuff is somehow moving, and that motion is what's keeping it together because of Ampere's law. If the parts weren't moving relative to them, each other parts in that, it would fly apart. Everybody understand? So everything has to be moving, and it has to be moving in a finite structure, so it has to, ultimately the motion has to come back to itself. Okay, so we have to be talking about circuits. There's no other way around it. That somehow the electron or these basic fundamental particles are circuits that are composed of stuff that wiggles around, okay? I don't see how to get around it. So the question is, how do they wiggle around? They have to wiggle around in a very specific way. And they have to be related to some kind of frequencies, because we can get fundamental frequencies for the proton and for the electron and for all these structures. We don't know what they mean, but they mean something, and they're not just there for no reason, right? All right, so what I'm proposing is what's been bothering me for literally over a decade is somehow or other we have to have, so let me take one step back. You've all been to a baseball game and you've seen people go the wave, and the wave goes around the auditorium. How long does it take for a wave to go around the auditorium? What determines the speed of that wave? The length is part of it, yeah. But that doesn't determine the speed. The length determines how long it takes, but it doesn't determine the speed. Okay? No, I haven't heard the answer I'm looking for yet. The answer I'm looking for, it's the reaction time of the people. It has nothing to do with space. It has nothing to do with some function of the auditorium. It's how fast do the people react to when the guy next to you does the thing, then you know you got to go. And people's reaction is not infinite. You don't react immediately. It takes you a little time. And that's the speed of the wave. Now, if you wanted to speed up the wave, I guess you could say, pick up the space, stand up quicker. But that's it. And I'm telling you that is exactly what the speed inside an electron is. I believe stuff moves around, and it can't move around at infinite speeds, infinite frequencies, perhaps, but not infinite speeds. And that speed, guess what that number is? Come on, we're talking, is there some special speed that we learned about somewhere? Yeah, come on, somebody said it. C, thank you. Okay, so the number C, I'm going to say something that's going to rock some people's boats, but this, I firmly believe it. C has nothing, absolutely nothing whatsoever to do with space. It has everything whatsoever to do with the elements that are composing matter. And matter reacts, and it moves in waves, just like the speed of the wave in an auditorium, okay? So it's this wave, which is not a thing. Again, the wave isn't a thing. The thing is the people, right? The wave is what the people are doing. And the same thing with this. The wave moves at c, but what's going on is we're getting compression and rarefaction. That's the word they used to use, where it gets close together. So stuff is wiggling around somehow, but it has to do it in a very specific way that's somehow related to frequencies. What that means is every place in my structure has got to have the same path length somehow on my principal directions. How on earth can you devise something so the inner shell and the outer shell are all have the same path length? That's what's been bothering me for over a decade. And I believe this is the answer. I believe what I'm going to give you is the answer to that, okay? And it has to do with something called Villarceau circles. Okay, this is a torus. What we're looking at is the two-dimensional skin, the outside part of it. Okay, if you take a look on the inside part and kind of do this little circle deal here, those two circles are called Villarceau circles after a mathematician named Villarceau. The radius of those circles is independent of how thick the torus is. It has to do with a family of tori that are certain characteristics I won't go into, all have the same Villarceau circles. And that's amazing. And they have the same path length. And here's the other point about it, is every point on the surface of that toroid has two unique Villarceau circles that identify that point. And they both have the same path length. That's super important. Okay? Now, I just want to clarify that point one more time. I don't know if you can see this clearly. There's a blue circle and a red circle, and they meet together on a green dot. You see the green dot? Okay. This is just a random point on the circle. Again, the blue circle has the same path length as the red circle. Now, all I've done now is I've spanned the space of the surface of the toroid. It's still only a 2D space, but I have to span a 3D space. But what I'm proposing is we can take a donut like this and spin it around in exactly the same radius, and I can end up with 3 dimensions that are all exactly the same path length. They have 3 principal directions, not necessarily at right angles to each other. Those 3 principal directions that span a 3 space, a finite 3 space. And so every point within my structure has the same path length to get back to where it started from. Why is that important? Because there's going to be waves going along each of these principal directions. And those waves are going to be related to each other according to these very numbers. What I'm proposing is that if, let's say, if it goes frequency fundamental along the blue direction, then along the red direction might be twice that. And along the one you don't see yet, let's say I'll call that the green direction, that would be 4 times that. And then that will create a doubling again along the red one. 8 times is just like 1 backwards, mod 9. We're going to get these same sampling points. And then we continue doubling and doubling and doubling all the way down, and every point is moving relative to every other point. It satisfies the conditions that I've been trying to satisfy. So given the third axis by sweeping the entire torus. Okay? So I believe this is as close to a valid model of the electron as we're going to get, as I'm able to get at this point. Still some work to do to get to actually prove it, but I think we're getting there. And I think these numbers, the Rodin numbers, are the numbers that we get it. So what I want to emphasize at this point is that the first axis has the frequencies 1, 8, 64, multiples of 8, okay? Which mod 9 are going to give us those special points. And then second axis is going to be 2, 16, 128, and so on. And then the third axis is going to be 4, 32, and so on. I'm going to get all the multiples, and I'm going to have a fundamental frequency. I believe I'm going to get all the characteristics that we know about the electron with this, and I'm going to satisfy all the conditions that are so demanding, that we can fill 3 space, and yet every point within the structure has a finite, the same path length to get back to it. That's what I'm proposing, and I think it's possible. And I think it's related to these numbers, because we can get doubling circuits, we can get double, 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 and get these same patterns with the Rodin numbers. So I don't think they're for nothing. I think they're really important. Anyway, we're almost done. Frequency, oh, this is cool. Let's see, frequency interaction. This is a little diagram that I showed you to explain the interactions of the numbers in the Rodin circuit. So I don't know if you can see these D's here. What is that? Boy, it is hard to see. D, -1, D0, and D1. What's going on is the red circle is moving around the blue circle, and then at the same time, the D's are moving around the red circle. So they circulate around the red at 3T, and then the red circle itself moves around the blue at 2T. Does anything in nature do this? I think we see relationships of 3 to 2. I don't think that should be that hard to find. Okay? So that's my proposal. Watch the movie for the pattern. What I'm going to do is show you the patterns. Now, we got the movie in here. Okay. So let's just follow the middle one, the D. Okay, just went through -3. Now it's going through 0, and now it hits -3, and now it flips around, -3 again, 0, 3, flips around, 3. You seeing it? 0, -3, -3. Recognize that number pattern? 0, 3, 3. We see that in nature. Now let's follow this one. This one goes 4, 2, 1. Excuse me, that would be +4, +2, it was -4, 1. Now we go to do, done. Okay, that one cycles the opposite way. Now let's take a look at this one. The other one, that one goes, where am I at here? Okay, 2, -4, and now it's going to go to 1, 2, 4. See it? 1, 2, 4. Okay? So this is giving us the Rodin numbers right here. And it's a 3-to-2 ratio in frequencies, which I think we can find things in nature that do that, or we can engineer things that do that for whatever reason. And these points are 9 points around there, but we get those magic points when they hit. There's something cool about that. And I think there's something engineerable in there. I don't know what, but you guys maybe can figure this out. Okay, got one more point and I'm done. There's a video made about 5 months ago. His name is Gerhard. Has anybody seen this video or know who he is? Nobody? Okay, this video got, what, 2 million views? Something like that. And the name of the video was, let me see if I can read it, Tesla's 369 and Vortex Math. Is this really the key to the universe? And basically, by the way, I just have to be clear, I love this guy. He's got a German accent, reminds me of Thorsten. And so I love hearing him, and he really knows his stuff, and he comes off great, and he has these beautifully, like, Hollywood style math videos, and he shows the equations, and he shows all the cool things you can do with them. So he spent 40 minutes going through and talking about modular arithmetic and all the different things you can do with all these different moduluses. The problem is he did not make any distinction between mod 5 and mod 9. He didn't show how any of the mods were different from anything else. He didn't show anything important about mod 9. And so his conclusion is, it's not the key to the universe. I mean, he didn't say that, but that's basically what you walk away with after you've watched this. And I contend, smart as he is, and as much as I love him, I really do, he really missed it. He missed the boat on this. He didn't get it. And I'm going to show you specifically what he missed. Okay? So the question is, what is special about mod 9? I already given you the answer, but I'm going to give it to you again. This is what's special about mod 9. Remember I said it earlier that the arithmetic moves, here I'll say it, arithmetic moves are also geometric. So in other words, moving 3 along the circle is the same. I can go from 1 to 4 to 7 to back to 1, okay? Or I can multiply by 4. 1 times 4 is 4. 4 times 4, 16 or minus 2 or 7. And 7 times 4 is back to 1, okay? Or negative 2 times 4 is negative 8. That's easier. Anyway, an arithmetic move is also a geometric move, and I contend that that is very special about mod 9. He made no mention of this whatsoever. He totally missed the boat. That's my opinion. 2 million people saw it, and they didn't get this. And this is the important thing. And it makes me mad. All right, so what I want to do is just quickly give you a reason why mod 9 is special. And can you all see this equation? 1 to the n, 1 plus n to the a. Binomial expansion, we should all have seen this. That is 1 plus a times n plus another term in n squared, another term in n cubed, and so on. Okay? But if we take that mod n squared, all those higher order terms just go away, right? Because mod, anything times mod n, times n squared, mod n squared, that's just 0, right? So I get 1 plus n to the a equals 1 plus an mod n squared. Well, turns out if n equals 3, then we got mod 9, don't we? So I say that's what makes 9 special. This is why 9 is special. Okay? This actually not the only reason, but this is one of the big ones. And so you can also multiply by b, and you can get both of those triangles. Okay? And that's all I'm saying right here. So let's just specifically, whoops, I skipped through one. Mod 9 tells you that 4 to the n, when I just plug this equation in, 1 plus 3 to the a, 4 to the a, 1 plus 3 to the a equals 1 plus 3a. And that's what we see here. 1 plus 3a is 4 and 7, multiplying by 4. That's what this equation is saying. That an arithmetic on the right and geometric on the left. Same thing with, next one is mod 25. Okay, 6 to the n equals 1 plus 5n, and mod 49, 8 to the n equals 1 plus 7a. Okay, so I think this is a big deal. Marco's going to talk about this a lot tonight. Talk about these different mods, the n square mods, but this is ultimately what it comes down to. This is why they're different than anything else. So we have one sequence of the Fermat numbers that's kind of special. We also have another sequence of the prime number squares. They have to be prime, and the reason they have to be prime is because otherwise you get counting twice. I won't go in, I don't have a picture to show you why it doesn't work, but it won't work when it's not prime. But it has to be a prime number squared. That's what it is, and that's what Marco's been saying for what, 3-4 years now? A while. This is why it has to be that. Okay, we are done. Time for review. Just a quick review. I just want to, before we're done, I'm not quite done. I mean, it wasn't that done. Okay, I just want to review, okay, and this will be quick. All right, so here's the point. Cyril, Rodin, and Phi all deal with resonance. I think we can agree with that. Okay. Modular numbers are expressed by roots of unity. It might seem like a kind of eggheady thing, but I think it's important, and it helps us understand a lot of these ideas. So I hope that's a takeaway for you guys. And the unit circle in the complex plane is powerful, way more powerful than we give it credit for, I think. Polygons with 3, 5, and 17 sides are constructible. We know what constructible means, and we know why they're constructible, and we even know how to do it if we had to. Okay? 4x4 magic squares and Rodin maps cohere like crazy. And we've seen that, and we've seen why, and we're seeing it happen. Okay. And there has to be something that we can get from that. Cyclic groups describe doubling, swapping, etc., and halving and other things. That's important. And another takeaway would be the function derivatives relate, these special functions we've been talking about, the derivatives relate to themselves. That's important. Final point is the number patterns could be frequency ratios. If we're going to model the electron, they could be other ratios. We could use them in a lot of different ways. That's up to you to figure out. But anyway,